warp drives. NASA has a warp drive project. Physicists now give chances of faster than light space travel. And they also say that we have the ability of putting space-time behind the craft, as we know in science fiction movies, and also that it would be possible to travel into the future, not into the past though, transport material, information, technology, transport, all this possible with the input of very little power. And all is possible with exotic material, such as monatomic gold and other monatomic elements. The closest star to Earth is Proxima Centauri, about 4.25 light years away, or about 25 trillion miles from us. The fastest ever spacecraft, the now in space Parker Solar Probe, will reach a top speed of 450,000 miles an hour. It would take just 20 seconds to go from Los Angeles to New York City at that speed, but it would take the Solar Probe about 6,633 years to reach Earth's nearest neighboring solar system, Proxima Centauri. This is an article by Mario Barunda, The Conversation. Now, if humanity ever wants to travel easily between the stars, people will need to go faster than light, but so far, faster than light travel is possible only in science fiction. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Some elements used in this type of science would be exotic matter, the hypothetical particles and states of matter that have exotic physical properties that would violate the known laws of physics, such as particles having a negative mass, meaning that they can eliminate gravity. That's what, and weight, having negative mass. And hypothetical particles, states of matter that have not yet been encountered. We have encountered them, though, in monatomic gold, but those properties would be within the realm of mainstream physics if found to exist. Now, several particles whose existence has been experimentally confirmed that are conjectured to be exotic hadrons and within the standard model, and states of matter that are not commonly encountered, such as the Bose-Einstein condensates, fermionic condensates, nuclear matter, quantum spin liquid, string net liquid, supercritical fluid, color glass condensate, and the forms of matter that are poorly understood, such as dark matter or mirror matter, and the exotic atoms, such as, of course, those that give negative mass, one of them being monatomic gold. And this is also explained in the Alcubierre drive, warp drive, the idea based on the solution of Einstein's field equation in general relativity, according to Wikipedia. Now, going back to the article, if humanity ever wants to travel easily between stars, people will need to go faster than light. So far, faster than light travel is possible only in science fiction, but it seems that even from antiquity, the reason for searching and finding, even in the ancient Greece legend of the Golden Fleece, it was all about monatomic gold. In Isaac Asimov's Foundation series, humanity can travel from planet to planet, star to star, or across the universe using jump drives. He says here, as a kid, I read as many of those stories as I could get my hands on. I'm now a theoretical physicist and study nanotechnology, but I'm still fascinated by the ways humanity could one day travel in space. And that, of course, could be done with the monatomic gold and other exotic elements, which have negative weight, which means anti-gravity. Some characters, like the astronauts in the movie Interstellar and Thor, use wormholes to travel between solar systems in seconds. Another approach familiar to Star Trek fans is warp drive technology. This is what we're talking about here. NASA has a warp drive program. Warp drives are theoretically possible if still far-fetched technology. 2 recent papers made headlines in March when researchers claimed to have overcome one of the many challenges that stand between the theory of warp drives and reality. But how do these theoretical warp drives really work? And will humans be making the jump to warp speed anytime soon? Compression and expansion. Physicists' currently understanding of space-time comes from Albert Einstein's theory of general relativity. General relativity states that space and time are fused and that nothing can travel faster than the speed of light. General relativity also describes how mass and energy warp space-time. Hefty objects like stars and black holes curve space-time around them. This curvature is what you feel as gravity, and why many spacefaring heroes worry about getting stuck in or falling into a gravity well. Early science fiction writers John Campbell and Asimov saw this warping as a way to skirt the speed limit. So what if a starship could compress space in front of it while expanding space-time behind it? Star Trek technology. This is what Star Trek took this idea and named it warp drive. In 1994, Miguel Alcubierre, a Mexican theoretical physicist, showed that compressing space-time in front of the spaceship while expanding it behind was mathematically possible within the laws of general relativity. So what does this mean? Imagine the distance between 2 points 33 feet apart, 10 meters. If you are standing at point A, it could travel 1 meter per second. It would take 10 seconds to get to point B. However, let's say you could somehow compress the space between you and point B so that the interval is now just 1 meter, then moving through space-time at your maximum speed of 1 meter per second, you'd be able to reach point B in about 1 second. In theory, this approach does not contradict the laws of relative science, since you are moving faster than light in the space around you. Alcubierre showed that the warp drive from Star Trek was in fact theoretically possible. Proxima Centauri, here we come, right? Unfortunately, Alcubierre's method of compressing space-time had one problem. It requires a negative energy or negative mass, and we have that with exotic elements such as monatomic gold. The negative energy problem? Alcubierre's warp drive would work by creating a bubble of flat space-time around the spaceship and curving space-time around that bubble to reduce distances. The warp drive would require either negative mass, a theorized type of matter, or a ring of negative energy density to work. Physicists have never observed negative mass, so that leaves negative energy as the only option. Now, to create negative energy, a warp drive would use a huge amount of mass to create an imbalance between particles and antiparticles. For example, if an electron and an anti-electron appear near the warp drive, one of the particles would get trapped by the mass, and this results in an imbalance. This imbalance results in negative energy density. Alcubierre's warp drive would use this negative energy to create the space-time bubble. But for a warp drive to generate enough negative energy, you would need a lot of matter. Alcubierre estimated that a warp drive with a 100-meter bubble would require mass of the entire visible universe. In 1999, physicist Chris van den Broek showed that expanding the volume inside the bubble but keeping the surface area constant would reduce the energy requirement significantly to just about the mass of the sun. The significant improvement, but still far beyond all practical possibilities, obviously. A sci-fi future. 2 recent papers, one by Axel Bobrick and Gianni Martir, and another by Eric Lenz, provide solutions that seem to bring warp drives closer to reality. Bobrick and Martir realized that by modifying space-time within the bubble in a certain way, they could remove the need to use negative energy. And this solution, though, does not produce a warp drive that can go faster than light. Independently, Lenz also proposed a solution that does not require negative energy. He used a different geometric approach to solve the equations of general relativity, and by doing so he found that a warp drive would not need to use negative energy. Lenz's solution would allow the bubble to travel faster than the speed of light. It's essential to point out that these exciting developments are mathematical models. As a physicist, I won't fully trust models until we have experimental proof, yet the science of warp drives is coming into view. As a science fiction fan, I welcome all this innovative thinking, and in the words of Captain Picard, things are only possible until they are not. And I'll leave a link below for you for The Lost Secrets of the Sacred Ark by Sir Lawrence Gardner. And it's amazing because he basically talks about the possibilities of what monatomic gold can do. And he does refer to the Exodus part of the Old Testament having to do with Moses and burning the calf, turning it into powder. Of course, just burning the calf would turn it into liquid gold, not white powder of monatomic gold, which is the monatomic gold that Moses mixed with water and fed to the Israelite tribes. And obviously that was monatomic. And how monatomic gold also is able to give us a transfer into another frequency in another dimension, and then reappearing into the material dimension. Amazing information what he has there. I'll give you the link to that, and it's worth watching it. It's a video of about 1 hour 20 minutes, full of information as to what the ancients knew about monatomic gold. As we know, the ancients did have very high technology knowledge and use of such exotic materials as monatomic gold for health and also space travel, and it's what we could be using now in this nanotechnology and monatomic gold, exotic materials for warp drive as well. I'll leave links below for you for this. Thank you for your support, and please leave your comments. Thank you.